Should I initiate, Dr. Yadav?
Yes, sir.
Fine. So I believe we have about 1 hour 15 minutes, and then we will restrict to discussions to about another 15-20 minutes. And if somebody can collect, if there are any questions, I request participant to put it in the chat box. Professor Yadav, it would be good if you can collect it to me, and then we will discuss it if there are any questions at the end. Will that be fine?
Sure, sir.
Okay. So let me initiate this discussion, friends. Thank you, Professor Yadav, for extending this particular opportunity, and it's our pleasure. It's my pleasure to join this particular discussion, and it is indeed very hearty to note that people are interested in joining even at a late evening. So what I'm going to discuss today with all of you is essentially some of the work that we did with my PhD student, and the work that I'm going to look at is spanning typically into 3 different areas. The first part that we are going to look into is the idea of a brain tumor segmentation, as we will look through that. And then the second part of it, that once the tumor is detected and the parts are segmented, we will look at the idea of a survival prediction. And then this itself is a difficult problem to deal with. So what we will do is then, apart from doing radiomics, which are like features extracted from images, can we look at something like a multiomics analysis as well? So in that case, what I try to show you is some part that we had been looking at combining genomics and radiomics. So that's the part that I would like to look at. I would like to acknowledge, of course, so this is a work that we had been doing with my PhD scholar. She just graduated this year, and she's a assistant professor right now at Bennett University. And then, of course, a couple of my colleagues, Dr. Mohindra Roy from PDU and Professor Rupal Kapdi, who was also an alum of Ahmedabad University, and then she's with the Nirma University. The thing that I'm going to discuss with you today is thanks to Professor Spyridon Bacchus, who started this particular challenge. This is known as a brain tumor segmentation challenge in 2012. I have seen this as one of the longest challenge which are hosted to do brain tumor segmentation in the world, and now it is still continuing in 2024. So previously Professor Bacchus was with UPenn, University of Pennsylvania, and now he is with Indiana University. And then Ujjwal was the student of SGSITS Nanded, and then he joined the team of Professor Spyridon Bacchus, and currently is assistant professor at Indiana University, who also helped us during this particular work to look at. So this is the agenda which I am setting up. I will try to introduce domain, then we will peek through brain tumor segmentation, then we will have a look at the problem of survival days prediction. I'll mention some typical inputs about the data set which we are going to look at, and then of course how one can use XAI, which is a full form of explainable AI, in this particular setting. So that is what we intend to discuss, and then we will look at what typically can be the extension of this particular work, if there are PhD scholars who would like to look at and would like to join this discussion and would like to take this work forward. Right. So to begin with, without wasting one of the time, what we are looking at is the idea of so from the image processing perspective, we are looking at the idea of a brain tumor segmentation, and what we are looking at is trying to segment type of a tumor, which in general are known as gliomas. And World Health Organization have created different gradation of this glioma depending on the malignancy and the aggressiveness of this particular tumor. So there are 4 stages as recorded by World Health Organization. Stage 1 and stage 2 are typically like a low grade gliomas, which essentially is like not very aggressive or invasive type of a tumor. And grade 3 and 4 is given a special name, which they call it as a glioblastoma multiforme, or in short we'll call it as GBM. That's the most aggressive type of a tumor. And as you can look at, it is a malignant tumor, and unfortunately the survival rate or the median survival rate of the patient who is suffering from GBM or glioblastoma multiforme is very meager or very poor actually. And there is no definite curative remedy, but typically the most safest which is like done in most of the tumor is that people would resort to resection. That means they will remove the tumor, and in this case we will call it as a gross tumor resection, or that is known as a GTR. And then once the tumor is removed, they will either fall back to the mechanism of classical chemotherapy or a radiotherapy. Now, before we go into the tumor segmentation, I should tell you that the type of images which we are processing in this case are magnetic resonance images, or they are typically known as an MRI images. So if you see this particular figure going from left to right, these are all MRI images that are available. So magnetic resonance imaging basically is based on a principle that it is a large magnet in the cavity in which the human body has to go, and that magnetic field is going to impact the water molecules that are present in the body. So it aligns them, and actually it radiates the electromagnetic energy. So these water molecules are gaining energy, so they are excited. And once this source is closed, these excited states, water molecules will go back to their original state, and while they are doing this, they will release the energy which are captured by these imaging sensors, and that's how the internal anatomy of the body is actually captured. So this is, and now what happens here is that you can control the amount of electromagnetic radiation or the frequency of electromagnetic radiation that one would like to look at. And therefore that gives rise to different modalities of an MRI scan. So if you look at the first MRI scan, this is known as a T1 modality. So T1 modality you can think of is like, it is good for giving you a gross structure of the brain and the brain tumor, right? Then what one needs to look at is that if you would like to look at some very specific part of a subpart of a tumor, right? So say for example, you would like to look at the interaction which the blood vessels are doing it with the tumor, or if there is some rupture that might have happened within the tumor and you would like to enhance the part in an MRI scan. So then there is this another modality which is known as T1CE. So CE stands for contrast enhancement. And this contrast enhancement will then sort of improvise on the contrast of the specific part that you are interested in looking at. And therefore, some specific agent like a gadolinium is given to the patient, and then this particular scanning is done. Then if someone is interested in looking at the fluid accumulation, right? Because you know that the brain is made up of white matter, the gray matter, and the cerebrospinal fluid, or what is known as a CSF. And what happens that when the tumor is is being created, what happens is that it will disturb the normal flow of the fluid that might happen across a normal brain. And you would like to look at where is that fluid accumulation that has happened. So for that, one can start looking at a modality like a T2. And then there is an extension to this T2, which is known as fluid attenuated inverse radiative part. So that is known as an flare image, wherein what it does is that it acts as a filter, and anything which is other than the fluidic part would be then subsided. You can think like that. So it's a filter which removes that particular part, and therefore flare is something like an extension to T2. Now, why I'm telling you this in detail is that you can appreciate that each of these modality is capturing different features of the brain tumor, and not single modality is good enough to capture different features. And then what our segmentation problem will boil down to, as I am showing you it on this particular slide. So this is a problem definition which we are looking at. So what we are looking at is that we would like to do a robust brain tumor segmentation. Once that is done, then we would like to do an overall survival prediction or overall survival days prediction for an MRI scan. Now, if you see this,